What's going on, everyone? My name is Johnny Bandon and I'm your CCNA instructor for this CCNA video series. And in this video we're going to go over static NAT. So it's going to be our first lab when we go over NAT. And in this lab you're going to see we just have a simple topology. And like some of my labs, before we jump right into configuration, let's just get our bearings right. So what we have here is, got a standing desk, let me move it up real quick. So what we have here is we have our DNS server that's going to represent our outside network, right? Our global, the internet. We have a router here that I changed to this nice little pretty cloud symbol that's going to represent our ISP connection. And then we have our inside network here. So we're going to do a static NAT translation for 192.168.10.5 out to 8.8.8.8. Well, really inside, outside, right? And then we're going to try to do the same thing for 10.10, see what errors we get, and just kind of prove how not scalable static NAT really is. But we're going to configure it, we're going to get it working, make sure that PC1 can talk to the DNS server, and then that's really going to be it. Some Wireshark captures, of course, verification, and we want to start out with static NAT because really, static NAT is easy to configure and it helps you get your bearings and kind of learn the terminology of NAT when configuration's easy. So let's go ahead and begin, and let me get my face out of here. We don't need to worry about that. We're focused on routing, switching, and CCNA right now. Okay, so we have our EVE-NG environment, and for our paid students and our self-paced online course, this lab is available to you with all the lab files and the iOS images. It's going to be, I can't close this lab because starting up these viral images that I'm using right now kind of take a while to boot up, but it's going to be available to you in our Google Drive link, these lab files. For our free students watching this on YouTube or any other streaming service, check out our EVE-NG tutorial to see how to set up labs just like this, how to get the images into EVE-NG. And we also have our GitLab, which is available for everyone, and it's going to be in the link below if you're on YouTube. And in this CCNA video course, you're going to have baselines, and then you're going to have instructions for every lab with the network diagram also here. So as you see, I'm going to drag this over to my second monitor, which is not seen by you, the audience. So if you're wondering how I'm just reading off instructions, I'm reading it on my second monitor. And I didn't just memorize the IP addresses. I'm using that network diagram on that GitLab page. So, first step is going to be turn on all devices. You do that by coming over here to more actions and start all nodes, which I've already done. And step 2 is going to be paste baseline from GitLab. So for our paid customers, the baseline configuration is already in the network devices, including the PC and this DNS server. So for our students that are watching on YouTube, remember that baseline is going to be on our GitLab repository at the root level. So it's just something you can copy and paste real quick. That's going to be step 2, paste our baselines. And then step 3 is going to be verify all IP addressing and routing. So let's go over what we've done here. So already, because we want to focus on NAT, I've already configured IP addresses at all of our devices and interfaces right here. And then I configured OSPF routing between these two just to make it nice and easy and simple. And then I also applied an ACL at inbound on interface gig 00 that's going to deny any RFC 1918 addresses. Similar to or exactly what ISPs do in the real world, because these addresses should never be routable out on the internet, and all ISPs at their provider edge connections are going to deny or have some sort of filtering mechanism that denies any private IP address to not allow it on the internet. So I've gone ahead and done the same thing, but of course we are going to verify all that first. So I already am consoled into all our devices. To console into devices in EVE-NG, you just click them, and then you open your terminal emulation program. Of course, we recommend secure CRT. So awesome. So first things first, let's go on R1. And don't worry about this message here. We have a duplex mismatch, and we can go ahead and fix that if we want. Duplex half. Okay, awesome. And let me just go ahead and turn off. That should be it. Monitor. And turn off any logging console so we don't see any crazy messages come up and interrupt our training. Okay, so R1, let's go ahead and verify our IP addressing. So we're going to go do show IP interface brief, include up. There we go. We like to use a little pipe commands and regular expression, right? So we are configured correctly. Gig 00 is going to be our outside interface. Gig 01 is going to be our inside interface. And let's make sure we're learning about that DNS server. So we have IP reachability. Awesome. Let's go to our internet router, do the exact same thing. So show IP interface brief, include up. All right, we can see its interfaces are configured correctly. This is our connection out to R1. And then this is the default gateway for our DNS server. Not doing any configuration on this side of the house. One last thing I just want to show you is the access list that we created to deny all the private IP addresses that you can see here and then permit any. And then that's going to be applied under gig 00. So if we look at gig 00, we're going to see that access list applied inbound. So meaning any packet that comes to gig 00 and the source address contains any IP address that falls within these ranges or networks, automatically drop, automatically denied. So now that we're fully configured, let's go ahead and just do some tests before we do our static NAT translation. Let's go ahead and ping 8.8.8.8. And I'm going to drag this off to the side here. And let's perform a capture right there. And let me show you what this looks like. So we're going to ping 8.8.8.8. Of course, we're going to be successful. One dropped right there. It's probably just even G-ism. And then if we ping 8.8.8 and we source it from our inside address, which is gig 01, it's unreachable. And if we look at our packet capture here, and that's because the source address is going to be that private IP, which the ACL we applied should be denying. So the message we're getting back from our ISP router is this administrative message under ICMP that says communication administratively filtered, meaning our private IPs are getting denied. So we need to fix that, right? We need to make sure that our user can reach the internet. So we're going to configure a static NAT translation for user PC1 so it can reach the web server at 8.8.8.8. And let me just go ahead and kill this Wireshark connection because we're going to do another one. So first thing we do is our NAT command. So we're doing a static NAT translation. So the command is IP NAT inside source static. And then we're going to define the inside address that we want to translate. And PC1 is .5. And then our outside interface is going to be 201.50.50.1. And then you can see we have other commands we can use here. We can define a VRF with it, maybe a route map for policy-based routing, but keeping it simple. And then our next step is going to be setting the outside interface. So interface gig 00, which is facing our internet connection, which is also going to be our public IP address, is going to be our outside interface. You can see I put a description here as well. So it's going to be IP NAT outside is how we define that interface. And you're going to see it kind of lag a little bit. And that's because in these virtual environments, NAT, it takes up a little bit of CPU processing. You're just seeing a little message here saying, okay, we see this process kind of being a CPU hog as far as the cores that are assigned to that router. Not something you're really going to see in the real world. It's just kind of a GNS3ism. And it sucks that those messages are still coming up, even though I turned off messaging or those syslog or those messages coming on the console there. That's okay. And then next we're going to define our inside. So now that we've done that, our next step is to perform a continuous ping from PC1 to 8.8.8. So let's check this out. So first, before we do that, let's just test from the router if we can ping 8.8.8 from this source of gig01, our inside address. And it's gonna have a big fat no. Why is that? Well, that's because we didn't say that this IP address can be translated. We said only this IP address. So you kind of see already the inherent flaws here, that this entire network, only one user can ever reach the internet. Now, if we do a ping from PC1, which is what we define as that static NAT translation, we're good to go. And we're going to keep this up because we're going to do some verification on Wireshark capture. So I'm going to move this secure CRT out of the way. Perform a capture on that gig 00. And before we look at that packet capture, let's go ahead and take a look at some verification commands on our NAT enabled router. So the first command we're going to look at is show IP NAT statistics. As you can see here, peak translation. So all the translations we had, all the hits, right? We can see our outside and inside interfaces defined. And then the next most important command is show IP NAT translations. And look at all this. Woo! But we can see what we already learned about, that the inside addresses, whether they're global or local, the port numbers are going to match. And then our outside local and outside global are also going to match. And you see it all matching here just because we're doing ICMP messaging, right? So if we were doing an HTTP connection to a web server in EVE-NG, this would be 80 and 80 or 443, 443. Awesome. So now if we look at Wireshark again, which is pretty cool. So we're doing a Wireshark capture on gig 00, which is our outside interface. So we just pause this here. We can see that the source address in our ICMP or our ping is the outside global address. Pretty cool. So we can see that it did replace that private IP in the IP header with 201.50.50.1, which is that public IP. If we do a packet capture on gig 01, let's see what that IP packet looks like on that ping. And as you can see here, the source address is going to be our inside local. So it's kind of cool, we can see it actually happening on the wire as well with our ping message, where that IP header, essentially that source address is getting replaced. Whereas that destination address, of course, isn't, because typically our outside local and outside global addresses are going to be the same. Let's get out of these Wireshark captures. That's good enough for now. Exit out of here. Okay, now without stopping that continuous ping, let's go ahead and try to make another static NAT translation for our other source static, for our other PC. So we're going to do 192.168.10.10, and then we're going to try to map it to the only public IP address we have, and it's going to say, that ain't happening. That already exists, and it's still happening right now. So if we go ahead and do show run pipe section NAT, let's go ahead and get rid of that line. We'll put yes, and let's try to make a different NAT translation. Awesome. Now we go back to PC1. Obviously, we're saying our pings are no longer making it, right? No longer doing that round trip. Now PC2, if we do that ping to 8.8.8.8, continuous. And actually, you see right here, I messed up this PC. I gave its default gateway 255, which is just a simple mistake that's easily fixable. So now we have the correct default gateway. And if we do our ping, we lost one because of ARP, but now you see that we're good to go. We look at our do show IP NAT translations now, that we are reaching that destination with our new inside local address. So you can see kind of like the inherent flaws, right, in static NAT translations. It's not going to work for any enterprise. Maybe this works for a weird data center where we have one web server and one public IP that's using a proxy server, maybe then we do static NAT. I kind of showed you in the previous sections, if you didn't watch them, where I use static NAT, and it was useful for me doing that Ansible connections and kind of changing it, the port number that's used for SSH. But that was like in a lab environment, right? So really, guys, static NAT, it's easy to configure. We need to know it for the exam, but when you see this in the real world, I really couldn't tell you. I've always just configured PAT or, pools, but still using PAT. So stay tuned for our next lab where we go over that PAT configuration. And that's going to give you a more real world feel, real world environment where we're going to allow a completely separate network to actually reach out to the internet. So stay tuned and thank you for viewing.